We're going to go over our earthquake concept map that was due today. So we're going to start over here where it says earthquakes are. So earthquakes are movements of the ground that are sudden. I'm going to underline the word sudden. Or a sudden release of energy when rocks along a fault move. And earthquakes occur at which plate boundaries? So they occur when two or more plates meet. And as we know, it could be divergent, convergent, or transform. So it also says frequent earthquakes in a given zone are evidence that two or more plates meet in that area. So when earthquakes happen, we have what are called seismic waves. The speed and direction of seismic waves are affected by Earth's interior. It's kind of like sound waves. If it's dense material, the waves will move faster, and if it's less dense material, it'll move slower. And if there's a change in material, say for instance going from the solid rock to the liquid outer core, then the wave changes direction or bends. And the definition for that is refracts. So seismic waves help scientists determine that the Earth is made up of three compositional zones, which is the crust, the mantle, the core, and 5 structural zones. And that'll be the lithosphere, the ionosphere, etc. So there's two types of seismic waves. The first one is body waves. And body waves are waves that travel through the body of a medium. And in this case, it's going to be through the Earth. There are two types of body waves, primary waves and secondary waves. Primary waves are the fastest. They arrive at the monitoring station first. The particles move back and forth in a parallel direction. And they can go through a solid, a liquid, and a gas. Secondary waves are a little bit different. They're the second fastest, so they get to the seismic monitoring station second. So that means after the P waves. These move side to side or in S-shaped motion. And these can only go through a solid. And lastly, we have surface waves. And these waves travel along the surface of the Earth. They arrive to the monitoring station last. They're the slowest of all the waves, and they cause the greatest amount of damage because they are on the surface where all our human-made structures are, our roads, our houses, etc. flip it to the other side. So let's start up at the top. Earthquakes are measured by three things: depth, or how far down the earthquake takes place; magnitude, the amount of energy the earthquake has; and intensity, which is the amount of damage that is done. Now that can only be measured after the earthquake happens. So let's start with depth. There's three depths. There's shallow, and these happen within 70 kilometers of the Earth's surface. There's intermediate, which are between 70 and 300, and there's deep earthquakes that happened between 300 and 650 kilometers of the Earth's surface. Earthquakes that have the shallow foci obviously do the most damage, again, because they're more up by our structures. And the deep foci earthquakes usually occur at a subduction zone and farther from the plate boundary, because subduction zones are the only ones that are able to go down deep into the earth. The other way we measure earthquakes is by magnitude. And magnitude is the measure of strength or energy that an earthquake has. And there's two scales that have been used, the Richter scale and the moment magnitude. Now remember, scientists now tend to use the moment magnitude because it's more accurate for the deeper quakes. And then lastly, the measurement is intensity, and that is the amount of damage that is done from an earthquake. And that has to be measured after. So going back up to the top, earthquakes can happen at all three plate boundaries. At a convergent boundary, they can have any type of earthquake, shallow to deep. So anywhere from right on the surface to 650 kilometers below. Convergent boundaries normally have some of the largest quakes, and some can even exceed 9. Remember, 9.5 is the largest quake that has ever been recorded. Now, divergent boundaries tend to have some of the shallowest quakes, anywhere from 0 to 30 kilometers. And normally divergent boundaries have a magnitude that is smaller than 8. Lastly, we have the transform boundaries. Transform boundaries usually have shallow quakes, anywhere from 0 to 70 kilometers, and normally their magnitudes are smaller than an 8.5. Lastly, the effect on humans. Now we know most injuries that happen from an earthquake are normally not from the movement of the ground. Most injuries and deaths result from the human-made structure effects of earthquakes and induced ocean waves. So tsunamis and the earthquake effect on buildings and roads and bridges and things like that. So that's what normally causes the damage from the injuries and death. It is not actually the earthquake itself. So, one of the first effects on humans, and we saw this with the Japan quake a couple years ago, is a tsunami. A tsunami is a giant ocean wave that forms after a volcanic eruption, submarine earthquake, or a landslide. Some other effects, I'm not going to list them all, but some other effects are the collapsing of buildings and structures, so these could be bridges and whatnot. Another effect on humans is falling objects. Another one would be flooding due to collapsing dams. Again, a structure that could be broken. Another one could be explosions, and these can be caused by broken gas or electric lines, or even oftentimes pipes under the earth. Broken glass, landslides.
Okay, our timber ticket winner is Abby Ruthenberg. Also at this time, Zach Kahulas, please come to the altar. Sylvia Stevens, Rachel Patterson, Claire Dombrowski, Katie Shanks, Alex Bratzer, Ben Adair, and Ainsley Kinney.
I'm sorry for the interruption. So the last two effects on humans were landslides and fires. Now I would put this somewhere safe, both pages, because this is all the information you're going to need for your test to prepare about earthquakes in kind of an easier format.